Hello everyone, today I'm going to present a review on journal about silica-based superhydrophobic nanocoatings for natural rubber surface. This journal is written by Veromi Kalpana Wimalasiri. Nanotechnology has recently gained the industrial attention as a sustainable way to solve many of the problems associated with the current society. It has been effectively implemented in many fields such as agriculture, water purification, energy, medical and polymer industry. Among these applications, many functional nanomaterials have been used in polymer industry in order to impart several properties to the products. The concept of superhydrophobicity has been widely exploited during the past decade due to the potential applications in impermeable textile, self-cleaning coatings, lab-on-a-chip device, microfluidic device, and glasses. A surface is defined as superhydrophobic when its angle is more than 150 degrees and the sliding angle is less than 10 degrees. In this journal article, it will focus on the development of a novel superhydrophobic nanocoating on natural rubber surface where the structural features, mechanical properties, and chemical resistivity have been studied and compared with those of uncoated natural rubber glove. An organically modified silica aerogel-based coating formulation was developed where an added polychloroprin-based polymer compatibilized the coating onto the rubber surface. There are a few steps used in completing the experiment. The first one is the preparation of silica-based nanocoating where the nanocoating was applied onto the natural rubber glove by deep coating and spray coating methods. Next one is the preparation of compatibilizer solution where the nanocoating and the rubber surface were compatibilized using an appropriate binder. Next procedure is the applications of silica nanocoating onto natural rubber glove by using deep coating method. Figure below shows the appearance of a water drop on uncoated rubber surface and silica nanocoated rubber surface. Next is the application of silica nanocoating onto natural rubber glove by using spray coating method where the silica dispersion was spray coated and was coated onto the glove surface. Based on this experiment, the result can be observed based on the properties shown. The first one is the mechanical properties. This reaction leads to a reduction of mechanical properties and chemical changes in the structure of the polymer matrix. Next one is FTIR characterization of natural rubber and coated rubber. In the coatings made by both spray and deep coating methods, the above peaks appear at the same position with a significant reduction in their intensity. This concludes that the methylene groups in natural rubber were unaffected by the interactions between the coating and natural rubber surface. Bonding mechanism between rubber film and the coating also can be observed through this experiment. The mechanism of the interaction between the nanocoating and the rubber film can be understood by referring to the chemistry between the silica aerogel, silicon sealant, and the polychloroprin binder. Figure 3a shows the coupling agents in silicon sealant and the silica aerogel are converted into their hydrolyzed state. This process is enhanced by the presence of atmospheric moisture deposited on the natural rubber surface. Hydroxy group of phenol formaldehyde interact with carbon-chlorine group of polychloroprin, forming a chemical bond with two matrices as shown in figure 3b. Peak due to the carbon-chlorine stretching frequency has disappeared after curing as shown in figure 3c. Figure 3D shows a possible mechanism for the structure of the nanocoating and binder after polycondensation. The flat orientation of the phenol formaldehyde ring structure provides geometrically favorable arrangement for the nanocoating to be bonded to the rubber matrix. Next one is the SEM characterization of rubber surface. Based on figure shown, the surface of the spray-coated glove appears to be rougher than the deep-coated surface due to the presence of nano-sized particles embedded within the matrix. However, SEM images do not provide conclusive evidence regarding the best technique to obtain higher hydrophobic characteristics. For AFM characterization of rubber surface, as shown in Figure 5, the three-dimensional surface of the spray-coated rubber surface demonstrates sphere-like shapes in its topological image. In comparison to the spray-coated surface, the deep-coated rubber surface has a relatively smooth surface morphology. This observation shows that the presence of thin and uniform layer on the spray-coated rubber surface helps to retain the mechanical properties of the original rubber matrix. Next is EDX analysis of superhydrophobic nanocoating. Based on the results shown in Table 2, it is possible to conclude that the coating does not contain any fluorinated compounds. Moreover, the presence of high percentage of carbon confirms that the coating contains silica nanoparticle modified with an organic modifier. Next properties is where the durability of the coating was measured by recording the resulting water contact angle after each abrasion cycle shown in Table 3 and in figure above. The initial water contact angle was 151 degree and 149 degree for spray and deep coated glove. Lastly, the permeability of nanocoating towards organic solvent and organic acids can be seen by SEM image in figure given, where this further confirms that the argument which there are no significant changes in the surface morphology of coated glove after exposure to methanol. In conclusion, superhydrophobic coatings on natural rubber surface were successfully fabricated using modified silica nanoparticle dispersion. In addition, the mechanical properties were maintained compared to the uncoated rubber matrix when the coating was sprayed. Next, the coating was durable even after being subjected to abrasion for a prolonged time. This observation, together with the FTIR characterization evidence, suggests that there are strong interactions between the coating and the rubber surface. Lastly, the coating were significantly resistant towards methanol, suggesting its potential in low molecular weight solvent-resistant applications. And that's all for my review for this channel. Thank you for your time and thanks for watching.